Hi, welcome back to my channel. In this video, I will demonstrate how to read the orientation sensor on Android and display the phone rotation on a Node RED dashboard. This is an improvement from my previous video titled Visualization Phone Rotation from Orientation Sensor in Node RED Dashboard Android, which utilized termux. In my opinion, the results weren't satisfactory due to slow processing. In this video, I'm using a slightly different approach, resulting in faster and better processing. Let's take a closer look. In this experiment, I've created an Android application that reads the orientation sensor values using Kodular. Next, at regular intervals, Kodular will send the sensor readings to an MQTT broker in JSON format. The values sent include azimuth, roll, and pitch. Then, Node RED will receive messages from the MQTT broker, which will subsequently display the received sensor values on the Node RED dashboard. The animation displayed will visualize the phone rotation obtained from the azimuth value. Here is the Kodular code being used. In the designer, there are several labels utilized to display sensor readings, including azimuth, pitch, and roll values. Additionally, there are buttons to start and stop sensor readings. The hidden components utilized include orientation sensor, a clock for the MQTT sending interval, and an extension for MQTT communication. Here are the Kodular blocks. Starting with the initialization of several variables, including a JSON variable for sending MQTT messages. When the button is pressed, the orientation sensor is enabled, and it starts reading the orientation sensor. Whenever there's a change in sensor values, they are displayed on labels for azimuth, pitch, and roll. Then, these values are sent to the MQTT broker with the topic orientation. This is the Node RED flow code. I'm utilizing flow variables to reset values, which will be handy for resets later on. Using the MQTT and Node to receive messages from the MQTT broker, we then employ a function Node to extract the azimuth, pitch, and roll values from the received JSON message. The received values will be displayed across various visuals such as gauges, text elements, and a UI template that will showcase an animation indicating the rotational position based on the azimuth value. The Reset Orientation button is used to reset the rotational position. All the code used in this video, including the Kodular code and the Node RED flow, will be shared. You can find the links in the video description. Here's the Node RED dashboard view, and the interface displayed in the Android application created using Kodular. Let's take a look. When trying to read the sensors, make sure your Android is far from objects containing electromagnets to ensure more accurate readings. In my case, I've positioned my Android away from tablet to enhance accuracy in readings. When we rotate the Android device, the display on the Node RED dashboard will change according to the Android's position, with data being refreshed every 1 second. To align the position of the Android with the display on the Node RED dashboard, press the Reset Orientation button on the dashboard, and the orientation position will be reset. Thank you for watching. In this video, we learned how to easily read sensor orientation values on Android using Kodular, specifically obtaining azimuth, pitch, and roll values. These values are sent via MQTT communication and received by Node-RED, then displayed on the Node-RED dashboard. This method is easier and faster compared to my previous approach using Termux API. It can be utilized for further applications such as controlling servos, among others. Don't forget to like and subscribe. See you in the next video.